while we're there on percentages or, areas.
This is fun.
So is it by county?
No,
Is state?
no.
Okay.
So, and we on 12, we don't use percentages because there are meteorologists that don't understand them.
Okay.
Now, the overall gist of we get. I mean, most people know that if they see a 20% chance of rain, probably not going to happen.
Right.
80% chance of rain, I'm probably going to get wet.
Mm-hmm.
But they think that means there's an 80% chance of rain and a 20% chance of no rain.
Mm-hmm.
It's not how it works. So basically what we're doing, or what the forecast models are doing, is they're picking out a point, unless it can be any point, a grid point. And we have the higher resolution models, like a 3 kilometer. So every grid point's 3 kilometers apart. That's really small.
Mm-hmm.
That's pretty good. So any point there, what they're going to look at, and I'll keep this simple. So the computer is looking at 10 previous days.
Okay.
Let's just say 100, make it easy. So it's looking at 100 past days.
Okay.
Over the however many years that had weather conditions very similar to today. So the computer is analyzing those past 100 days that have similar conditions to today in that one point. And of those 100 days, 62 had rain.
Oh, okay.
So the computer says there's a 62% chance of rain at that grid point or immediately around it.
Wow. Okay.
So that's how it works. So it's not county. It's not, it will or won't, or same thing. It's looked at 100 days and only 10 had rain near that grid point. So there's only a 10% chance of rain. So again, it's looking at past data on very similar, no 2 days are exactly alike.
Okay.
Which is, again, an exact science. But it's looking at very similar, like, okay, all of these days had humidity in this range, winds in this range, temperatures in this range, and so on and so forth. Computers can solve this, stuff. Right. And I'll stop right here. I go to school talks. I love school talks. I always talk, especially little kids. They get a kick out of this. I'm a math guy. I tell them that. I love math. And I'm like, okay, I'm going to go solve math equations to come up with today's forecast.
Okay.
Not tomorrow, not the next 10 days, only today, just today. And I say, will you wait for me while I do a few math problems? They're like, yeah, that's fine. And I'm like, okay, how long am I going to be out in the hall? And they're like, 2 minutes, 5 minutes, 10 minutes. I stop. I say 30 years.
Wow.
For just today's forecast, it would take me 30 years nonstop math problems, no sleeping, no eating, no nothing. 30 years of nothing but math problems to do the forecast for just today.
Oh my goodness.
And again, 25 years ago, computers, it may have took them 6 to 8 hours to do that. They can do it now in an hour or two. I mean, that's why forecasting has become way more accurate, because computers just get faster and faster and faster. They're solving these math equations faster than ever before.
And more data.
Yeah, and more data. I mean, we have these high resolution models, and those are the really pretty ones. Like you see Future Track, it almost looks like radar is going to be.
Right.
I mean, those things are so high resolution. They're updating every single hour. We get updates. Think about that. It's every hour we're getting new, information on where it's going to rain or snow or temperatures, or all this stuff. It's just so quick. It's unbelievable how fast they are.
Yeah. And the ones like, like that you can find on the app, is that a predictive of what it might?
I tell people, I love saying this and they always laugh. It's not the gospel.
Right. Right.
It's a gauge.
Okay.
That's why if you watch me, I will say, here's what radar may look like at 5 p.m. Yeah. It doesn't mean it's going to be raining exactly in Hutch or Newton. It just means that somewhere in this area, there's most likely going to be storms. It's not, if you go that to a T, you're going about the wrong way. Once the storm forms, it's different. Now, that's thunderstorms. When we get to these like winter storms and like the leading edge of the snow, those are a little bit easier, because that's just one big precipitation mass. Storms are, pop up here and there and fall apart so quickly. They're very complex, very complex. And actually it's really hard to form a storm, and it's extremely hard to form a tornado. Okay. And that's why we see so few of them. But these big storm systems like we get, and sometimes it's rain or snow or both. They encompass the whole state. Those are a lot more accurate. If we show that like in January and it says it's going to start snowing at 4, it's probably going to start snowing around 3:30 to 4:30. You can be really, really, accurate on those.
Okay.